Welcome to Ask and Learn.
Although this chapter is on coordination chemistry and transition metals, which we are seeing in this problem because we're dealing with titanium, this problem is also pulling concepts from ideas such as solid-state chemistry and redox chemistry, and we're going to see that in this video. This is what our structure is going to look like. This is why we have solid-state chemistry. We can visually see it like this. The red atoms are oxygens and the blue atoms are titanium. And what we can do is we can analyze this to find the number of titanium atoms. This is a body-centered cubic unit cell. We have, as you can see, titanium atoms at each corner, and we have one in the center. So we can find the total number of titanium atoms. We'll take 8, because we have 8 corners, multiplied by the fact that we have 1/8 atoms at each corner, and then we'll add 1 atom for that center atom. We'll get 1 plus 1, and we'll find that we have 2 total titanium atoms. And if you know a little bit about solid-state chemistry, you know that this makes sense because we're in a body-centered cubic cell. Now let's analyze the reaction we're given, because now, again, we are dealing with titanium, and now we have to analyze oxidation states, which is a huge concept in the chemistry of the transition metals. We have this reaction of 2 titanium dioxides plus 3 carbons plus 4 diatomic chlorines, and will form now 2 moles of the titanium bound to chlorine plus carbon dioxide and carbon monoxide. Now what we need to do is analyze the oxidation states of each of these atoms in the reactant and the product side. We know that every single oxygen atom has a -2 charge, and we know that the carbon is -1. Now when we compare these oxidation states, what we see is that the oxidation state of carbon increases from 0 in the reactants to 2 in the products, which means because of this increasing oxidation state, carbon is oxidized. And chlorine, what we see, chlorine's oxidation state decreases from being 0 on the reactant side to -1 on the product side. So chlorine's being reduced, which means it is an oxidizing agent. It's causing the oxidation of carbon. I hope that this problem helped you understand a little bit more about how we can visualize the transition metals, more specifically with solid-state chemistry, and hopefully this is an introduction or possibly review to understand how the oxidation states can change in a reaction using redox chemistry, and more importantly, we see oxidation states change when they're bound to transition metals.